I think we're ready here. Let me get that out of the way. I'm Paul Grimes. I'm with AMD, and I work in our server firmware division, working on platform firmware and openSIL and working on new open source initiatives in general for AMD firmware. And I'm going to start out by giving a little background on what openSIL is, why it exists, and a little bit about it, some background on AMD's firmware in general. Traditionally, what we've been using in client embedded and server silicon at AMD is called a GISA. It's AMD's generic encapsulated software architecture, and it's done a lot of great things from us. We just announced our 9005 series EPYC processors, codenamed Turin, and those are running on a GISA-based firmware stack, and we like that. But there's a lot of things that we want to improve about a GISA. One of the problem statements that we've identified from it and have had identified to us by our customers and users is its implementation as a UEFI EDK2 based solution, and its closed sourceness kind of limit our users into developing an EDK2 BIOS for it. So it's clearly targeted for UEFI host firmware, an EDK2 based host firmware, and we wanted to expand opportunities for users beyond that, and that kind of introduced openSIL. It stands for Open Silicon Initialization Libraries. It's the UEFI requirement is removed. It's written in standard C, and it's agnostic of any currently architected host firmware standard. So we would want a UEFI EDK2 solution to be able to interface directly with it, a core boot or boot, or any other firmware architecture to call these libraries directly. It targets our x86 phase up until OS handoff, and in the AMD Silicon environment, we have a pre-x86 phase, where we have a PSP processor running. We do some memory init and PCI init in that phase, and then hand off to the x86 reset vector and continue boot from there. So, both a GISA and openSIL are targeting that x86 phase. In doing this, we want to expand AMD's footprint and presence in the open source space. We want to build better relationships with the open source community, and we want to encourage people to come up with more unique solutions and in how they engage with AMD Silicon. So kind of what's in there, what's in openSIL, it's going to capture our silicon init code, AMD specific firmware features, APIs for silicon specific accesses, boot time features, and runtime features that are specific to AMD Silicon and need to be initialized at boot time, things like that. What we will not have in there is any host firmware specific code, so it doesn't have a concept of the EDK2 boot phases like SEC and DXE and PEI and things like that. Industry standard table generation is not there. With the data for that is available for a host firmware to access, and no binaries exist in this part of the code, and no non-x86 based firmware exists there. OS specific features we want to be handled by the OS. And here's kind of a map of the development timeline of it. We've gone through 2 phases of proof of concept on SP5 socket AMD EPYC Silicon, and also on a Phoenix client platform. We started with Genoa late 2021, early 2022, and proved out a POC there where we did kind of a mechanical rewrite of specific functions in GISA into openSIL, and did boot testing there. We open sourced that code to GitHub at GitHub/openSIL in mid-June of last year, And Turin POC we wrapped up earlier this year and are on track to publish our Turin openSIL proof of concept code end of this year, along with the Phoenix proof of concept as well. The goals for both of these proof of concepts were very kind of AMD focused initially. We wanted to, literally prove the concept of the firmware re-architecture and make sure that it was a viable product that we could switch to in a production environment. And, we feel we succeeded there. So we are moving on to, production with openSIL on our 6th generation EPYC processors first, and we'll be following on the Ryzen processors as well. Yeah, so a little more on the POCs. We just wanted to hit that technical analysis, make sure that we were ready to switch from AGISA to openSIL, and we kind of made a late decision in our POC work to open source it. A lot of that was to just give a show of faith to the community that we are publishing code. We didn't want to say in early 2022 that yeah, we're going to open source this stuff in late 2026 and everything's going to be NDA until then. It didn't have a nice ring to it. So we have a lot of code out there for Genoa now. We have a full EDK2 stack and the core openSIL code and the PSP firmwares that can all be worked with to create a build and bootable solution on Genoa, doing the same thing for Turin and Phoenix as I mentioned. And yeah, so these samples that are out in the public space now are truly a POC. They're evaluation code only. It's not for production. We don't have official support for it, but we're on track, and that will change for our POR products in starting with the EPYC Gen 6 line. Yeah, so sorry, I've got a little bit of a repeat in here. So the Turin POC is the focus here, and it's very much the same as what we did on Genoa. We have a larger set of code that was converted. We achieved full feature parity with our production AGISA based stack up to like a 0.8 level, which was May of this year is when we hit that. So the openSIL code, a small layer of AGISA v9 and our production EDK2 stack were at parity with the full AGISA v9 stack and EDK2. And that code is being worked right now to be prepared for open source. Again, as evaluation, these POC products and the style of release isn't reflective of our production code that we'll be having on our POR products. We will have a lot of that code is going to be we're working out governance models and community engagement models on how to not just drop code out there, but provide support and have engagement and feedback into it. And again, the 6th gen EPYC and Ryzen are POR with UEFI, and we're on track there. We've begun pre-silicon work on that code, and we're excited to move on to production finally. And what I'm really excited for in this presentation is that Tim and Insyde have done some great work to engage with it, and he'll talk about that.
Great, thank you, Paul. Thank you, Paul. My name is Tim Lewis. I'm with Insyde, and I need to address the elephant in the room, is this raging debate that's going on within the firmware industry. And that debate is whether it's UEFI or UEFI. Or, as I heard earlier this year, WEFI. For the record, I think, Dong, we've been with this long enough that we started out with EFI and went to UEFI, so that's my official definitive definition. Now, what happened was when we heard that AMD was going down this openSIL route, Insyde asked ourselves a challenging question, like, what were we going to do with this open source initiative that AMD was presenting at Insyde? And so what we did was we looked at a few areas where we had some expertise, we look for areas where we could contribute. And one of the areas that we came up with was in the relationship to the debugger. And we looked at the current existing solutions within the UEFI ecosystem and looked at them, starting with, if you look out there now, the source level debug package. Well, that is a debugging solution, but unfortunately the host application has disappeared from the website. It's no longer available. There is a GDB stub, so if you want to use GDB, you can use the stub that's out there in the embedded package. There is, from Microsoft within their Project Mu, they have the debug feature package, which does have some things, but works only with WinDebug, if you want to go that direction. Of course, they have hardware debuggers. AMD has HDT. It's a great hardware debugger for this solution. And there's, of course, some third-party software debuggers, including ones that are offered by Insyde, AMI, and Phoenix. But they're very capable, but they're proprietary. So there wasn't a good way, open source way to debug AMD, openSIL, and UEFI. IBV and hardware debuggers are great, but they force a decision fairly early on in the people who are evaluating openSIL to say which solution they're going to go with, because they can't debug the code unless they were to get one of the hardware debuggers or one of the proprietary ones. With OpenDBG, we actually give source level debugging capability for openSIL under EDK2 for firmware. It works with the standard GDB app. If you go to Linux now and actually go to and plug it in and plug this component into your UEFI firmware, you can actually establish a connection and do full source level debug, which I'll show some screenshots in a minute. And this code has been licensed under the BSD2 clause patent license, which is the same license that all the rest of the Tiana Core code is licensed under. I'll give you the URL for it later. I will tell you that if you go look at that URL right now, it's not there. It's because I actually haven't made it public until after this presentation. But later today, I will make it public. It's all checked in. You can grab it. You can go. The usage is very typical in the sense that it connects to the target platform using a serial cable. The GDB stub driver registers exception handlers, and that you can use all the exceptions, or the CPU breakpoint library function will actually cause the communication to happen with the GDB host app. And then GDB sends commands to establish and read the current debug context. Now, what happens for openSIL is that for each phase of boot during UEFI, there's actually a separate UEFI driver. All it is a wrapper for the call, the three different library calls, the TP1, TP2, TP3 driver. So there's actually three separate little drivers under there, but you can actually use this to debug all three of those drivers all the way down into the depths of openSIL. So basically it looks kind of like this. You have the openSIL. openSIL has EDK2. Inside that is the OpenDBG drivers that we're providing. So what do we actually do? We actually created a UEFI compatible driver that communicates using the standard GDB protocol, licensed under the same license. Same as basic instructions. There's instructions on how to set this thing up. There's nothing magic about it. It's actually fairly simple. Same commands that if you use GDB, it's the same commands you would use for there. These are just a couple screenshots. I'm looking at the time here. But these are just a couple screenshots. You can see that this is source level in one of these drivers, just shortly before we're going to call to the test point. You have both the source level, you have the assembly language disassembly, and then you have the command prompt. Here, one of the things that we did do is we allowed the debug output that comes from the firmware to be intermixed with the output from GDB. So you can actually see the output of the debug messages showing up on the same screen. So you can see here that all the modules being loaded, all the test points coming out from the firmware. We also added a few extensions. One of them is just a simple extension to allow you to dump the contents of enumerate the PCI devices within the system. Now, right here, this is within the AMD driver. It's just about to call the first test point, source level debug. Then we'll go one level deeper. This is actually inside that test point. source level again. So you're actually basically able to walk through the entire openSIL initialization process line by line from the source code, dump the registers, look at things, get actual valid information. Something that hasn't been possible with before unless you had the Agisa source code in your back pocket. It wasn't possible before, but now you can. And then here we went all the way down into one of the leaf functions and dumped the source code. So what are we planning to do with this? We still plan to continue working on this. We want to do some specific EDK2 stuff, EDK2 specific data structures, dumping of some of those. We don't support the debug port protocol, which is in the UEFI spec currently, which is supposed to abstract the connection to the transport layer for the GDB protocol. We haven't done that yet. We did finally complete sharing the debugging console over the same serial port, and of course WinDBG. That was something Microsoft had added to their version, and we haven't integrated that support into ours as well. Call to action: hey, go check out openSIL. This is your bullet point. Why am I saying this? Anyway, stay tuned for future AMD openSIL proof of concept and production releases. And you can go to as soon as I make the repo live, you can go read the instructions and download the source code yourself.
Yeah, absolutely. And thanks for listening, and thanks for your time. And again, yeah, we encourage people to check this code out and experiment with it. And that's great. And feel free to reach out. So have a good day.
Questions?
This is very good for developer engineers. So how you do you have any method to distinguish debugger BIOS and the production BIOS, disable the interface, something like that, when you shipping your product?
I mean, that really depends on the host firmware environment, right? It's not that the debugger is either there or not there, and that's up to the provider. So yes, Insyde has a method of doing that, but whether there's nothing inherent in the module that we created for UEFI which does. But you're right, that is a problem. Don't leave your debug interfaces there.
Hi, this looks awesome. Does OpenDBG work on platforms that don't have openSIL?
We have done some initial testing on other platforms, and so far they are working there. But our primary testing for this, getting ready for this thing, was on openSIL. So it should. I mean, there's nothing specific to it. We just haven't done the validation to make sure that everything, it should work just fine. We did test. We tested on Intel also, but it worked, but we didn't go through the full validation cycle. So, late question.
Have you actually ended up using this to debug something that was broken or not quite working in your development?
Currently?
Yeah.
Not yet. So we literally finished it to get ready for OCP. And we did go through a validation cycle for the tool, but it hasn't been used by our other engineers. We at Insyde are planning to integrate it in our next generation product for the next generation. So it'll be the chipsets, which are going to be probably the chipsets that Paul was talking about. We probably will using this to debug that, because we will integrate it into our debug tools. But we haven't for real life. Well, not quite. Fully open there. All right.
We are right on time.
Thank you so much.